another questions from this weekly contest. And later on, if you like this video and want more from me, please subscribe and click the like button. Also click the bell icon if you would like notifications for whatever new stuff I'm publishing. So let's start with the problem. It's about minimum consecutive cards to pick up. Basically, we got an array of integers called cards that represent the cards number and the value of the ith card. A pair of cards are matching if the value are the same. And then we ask to return the minimum number of consecutive cards you have to pick before you get until you get a pair of matching numbers. So in this case, so it means that how many cards you pick. Let's take an example here. In this range, so if you pick, the duplicate will be 3 and 4, right? So if we pick 3, it means we need to pick 1, 2, 3, 4, 4 consecutive pick until we get the pair of 3. If we choose the pair, the matching pair is 4, it will be 1, 2, 3, 4. So another 4. They are the same. Which one the minimum? It's the same, so it's 4. While this one, 1, 0, 5, 3. There is no duplicates value, so there is no matching pair. So we return -1 as per required. For the constraint, there is nothing interesting there. Everything can be pretty big numbers. The cards will be always positive or 0. Non-negative basically, and we always have at least one card. So I think the key points is to understand what does it mean by consecutive cards. Okay, so now we are talking about the tactics to solve this. So the key point is here, where it means that the problem is asking the delta between the matching, and we want the minimum delta between the matching, distance between the matching. That's another way to actually translate this sentence into something that is more programmable. So that's it. Okay, it's about the distance between the matching pair, or -1 if there is no matching pair. Now, how to solve this? So to solve this, it means that we need to take into account all the, all the duplicates we found, and whenever we found the duplicate, we measure the distance, and once we measure the distance, we also need to measure which one is the minimum distance, and then at the end we return the minimum distance. So that gist of it. Now, how to make it efficient? Whenever we are handling cases about finding duplicates or something that is the same value, what comes into mind always is a hash map, which is a dictionary in Python. I'm going to implement this in Python. So that's it. That's one of it. Now, the way I'm going to solve this is basically I'm going to scan through the numbers, and for each scans, I will store it into the hash map so I can detect for duplication or matching pairs. Whenever we met matching pairs, it means that when we detect that was something already there before, then we measure the distance. In order to measure the distance, it means in the hash map we need to store the position, the index. Then the distance will be just the delta of the index. Okay. So for example, let's take an example of here. How this going to be run is this. So we're going to store it into some hash map. So in our storage, then we're going to scan it from left to right. So first we got 3. 3 is not exist yet, so we initialize it, and the index was 0. Then next we got 4. 4 also non-existent yet, the index of 4, which is this one, is 1. Then we go here, number 2. 2 also not exist yet. The index of number 2 was 2. Then we got here, it will be 3, and the index was 3. Oh, no, 3 is already exists, right? Here. So what we do is we add it here, 0, 1, 2, 3, which is the index 3. And we know there was something already there, so we calculate. Previously, the minimum card picks was none because we don't have anything yet. But now we find some matching pairs. Now 3 minus 0 plus 1 will be the distance. So there will be 1, 2, 3, 4. 4 cards. Basically the number of cards is the distance plus 1, right? It's the delta plus 1. So it will be 3 minus 0 plus 1, which is 4. Now it becomes 4. Now we go to here, 4. 4, we made another 4 there. The current 4 have the index of 4. And then we try to update 4 minus 1 plus 1 is the minimum card to get the matching pair of 4. So 4 minus 1 plus 1 is 4. 4 and 4, it's the same 4. And then 7. We don't find anything yet for 7. So 7 with the index 5. And that's it. And we got the minimum card for this, which is 4. So that's about the tactic. Now we implement it. So we need this to start, and that's what we're going to return later on, the minimum cards. And we also need the data structure to maintain the matching pairs. Okay, so it is basically whether we already visit the value before, and it will be a dictionary, which is correspondence of hash map in Python. And then because for each of these, remember later on whenever we met another matching pairs, we're going to do a minimum comparison with the existing one. Because we initialize this with none, let's create a helper function to help us handle the none. So when we compare two values of minimum, if one value is none, we just relent the result of minimum towards the other one. Because none compared to any number, the any number become the winner of the minimum. None means just we haven't do any calculation yet. And finally, if both of them are not none, we just use the default function from the built-in function in Python to do comparison to get minimum. Now let's do this logic we do. Basically we're going to scan the input. The input was cards, right? Yeah, input was cards. So scanning the input, and then for each input we're going to check whether it is inside the visited hash map. If cards I, if it is not in visited, we're going to initialize it, because the initial one definitely empty visited, right? So we're going to initialize the visited values with an array, a list, where this going to contain later on the index for each that we find. And for this, the index definitely the I itself. But if it is already visited before, then what we need to do is we need to append the list with the new I. And also, if it is already visited before, it means we map the matching pairs. So the matching pairs will be the distance, the new distance, basically, let's say consecutive card, cards number for this case that we just met is basically the last index minus one before last. And it's guaranteed that we at least has 2, right? So the minimum cards now can be updated. The minimum cards is get min from itself or the new distance card numbers that is needed. Oh yeah, just now we need to make it +1 because remember there's now 0 minus 3, 3 minus 0 is 3, but in terms of cards we need to include all the elements in between, so it will be needing to be +1 and then min cards. And we also need to remember that when there is none, actually there is no matching pairs, we need to return -1, not returning none. We don't initialize this with -1 because it will mess up with the minimum comparison. Therefore, we need to handle this a little bit differently, that it will return -1 if min card is none, otherwise we return the min card's value. Okay, it means if min card's not none, it means that we met a matching pairs. Now that's about it. And another thing why maybe I need to emphasize why this works, why we just need to consider the last in between. Because whatever is the case, in case we met another number 3, for example here, okay, so if we met another number 3 here, the index of this one will be 3, 4, 5, 6, so it will be index 6 and it will be entered here, right? So whatever the case here is, the smallest distance can only be in between here or in between here, because if we made it here, definitely it is larger than either of the other 2 previous choices. That's why we only need to always consider the last 2. So the first we find the second, we calculate this. The second we find the third, we calculate this and then compare it with the answers. Now we got already implementing it. Let's try to run some sample case. So our answer and the expected one is the same. Now let's submit it to check whether this is efficient enough to be accepted as a solution. Yep, it is. So now let's do the time complexity analysis. The getMin itself is just a comparison. So this is a big O1. Let's minimize this. This is just initialization. This looping is big O and because it looped for its card. And then instead of this is just an if else. Doing this in the hash map is just big O1. And then all of these are just big O1. Getmin also big O1, right? So this is kept as big O(n). This one is just comparison also, so this is just a big O1. So because all of these are sequential, the time complexity will take the big O1 plus big O(n). So in the end, we take the largest, so this is actually having a big O(n) time complexity. So that's it for today. Thank you.